Alright guys, today we're going to look at another method for multiplying polynomials. This method we're going to use is called the table method. I've seen it called other things, but this is just kind of what I've come to call it over teaching it. And so the table method, I've got 4 steps that kind of go into that, and then I've got an example we're going to go through and kind of take you through these steps so you can kind of see them in action. And you can see those steps listed. You got to determine the size of your table, draw your table, fill it in, and then combine your like terms. And so looking at the example I've got here, I've got 3x squared plus 2x minus 1 times x cubed minus 5. And so one of the things I want to talk about, the big benefit to the table method, besides that it's very visual and it's very well organized, is you can multiply any size polynomials using the table method. And so the FOIL method is another one that I've made a video about, which is pretty commonly used. The FOIL method is great for multiplying 2 binomials, but once the polynomials start getting larger, that gets more difficult. And so the table method is one a lot of my students have really come to like. So step 1 is to determine the size of my table. The way you do that is you count the number of values within the polynomial. And so looking at the first one, I've got 3x squared, that's 1, plus 2x, that's 2, minus 1, that's 3. Okay, and so there are 3 values in this polynomial, and then the other one, it's x cubed minus 5. There are 2 values, so my table is going to be a 3 by 2 table. And so that's how I make that decision. And that, of course, gets me to step 2, where I'm going to draw the table. So I'm just going to draw a pretty simple table, 3 columns, 2 rows. I have people ask me, does it matter if it's 3 by 2 or 2 by 3? It doesn't, as long as you put the proper size polynomial in the right place. And so here I've got a 3 by 2 table, just like that. I'm going to go ahead and put my polynomials where they belong on that table. So I've got 3x squared plus 2x, and then I have minus 1. And then the key there, make sure to remember that negative sign that goes with that. And then on the other part here down the side, I've got x cubed minus 5. And so that kind of covers those first 2 steps there to determine the size and to draw the table. And now I'm going to fill it in. And this is where you have to remember what you're doing here. The whole point of this is to multiply these polynomials together. So I'm basically going to multiply at whatever 2 expressions intersect at that particular square on the table. Okay, and so looking right here, I've got 3x squared is going to intersect with x cubed. So I'd multiply 3x squared times x cubed, and I get 3x to the 5th. And so that's how I'm going to multiply that. Then moving to the next square to the right, 2x times x squared, 2x times x cubed is going to be 2x to the 4th. And then I've got negative 1 times x cubed gives me negative x cubed. Then I'm just going to hop down to that next row. 3x squared times negative 5 is negative 15x squared. Then I got 2x times negative 5 is negative 10x. And then finally, I've got negative 1 times negative 5, which is going to be a positive 5. And so that completes step 3 of our table method. We filled in our table. What's inside this table in blue is my answer. This is the result of multiplying these 2 polynomials together. But I do need to go ahead and write that as a proper expression, as a polynomial. And in doing that, I need to combine the like terms that I have. Now, in this particular case, it worked out in such a way where I actually don't have any like terms within the table. If you start going from highest to lowest exponent, I've got 3x to the 5th plus 2x to the 4th minus x cubed minus 15x squared minus 10x plus 5. And so it actually worked out that my final answer had absolutely no like terms. But if there were 2 values in there that were like terms, I would go ahead and combine those at this time and then write those out in my final response.